Okay, so third video on solving systems of equations by substitution. Just as a review, a system of equations just means we have more than one equation. It means that we are not solving each of these individually. We're trying to come up with a solution that works for both equations. So when I come up with my x and my y value, it should solve the top equation and the bottom equation. Most of the time, there's going to be one possible solution. Sometimes there could be an infinite number of solutions, or there might be no solution that works for both equations. If we think about graphing, we could graph both of these lines, and we get two straight lines. If they cross at one point, that point where they cross is the solution. That means there's one solution. If one line is parallel to the other line and they never touch, that means there's no solution. And if one line is exactly on top of the other line when we graph it, that means there's an infinite number of solutions. I'm going to solve by substitution, though. We're not going to graph this. Just going to do a review. So first, I'm going to notice, well, I see up at top it says y equals 2x subtract 3. That means wherever I see y in the bottom equation, I could actually substitute in for y and put 2x subtract 3. So that's what we're going to do. This is already set up pretty nicely to do that. So I'm just going to go ahead and replace y with 2x subtract 3. So I write 3 times. So now instead of y, I'm going to write 2x subtract 3. And then I just write the rest of the equation, plus 7, and then equals 4x. So now for the next step, I'm going to do the distributive property, which means I'm going to multiply 3 times 2x and 3 times negative 3. That gives me 6x subtract 9. Now I just say still plus 7 equals 4x. So now I have like terms on the left-hand side. I just look at one side of the equation at a time. So I have negative 9 and positive 7. So I can combine those and say 6x subtract 2 equals 4x. Now I say, okay, well, I don't have any like terms on the left side. I only have one term on the right side, so I can't have any like terms. But I do have like terms across the whole equation. This is where we start moving stuff back and forth, adding and subtracting numbers. So I'm going to go ahead and I'm going to say, all right, well, I need to get all the x's on one side of the equation. So what I'm going to do in this case is I'm going to start with the lowest coefficient of 4x. This is actually going to be a good problem because I see this mistake a lot when people do it. And I'm going to say subtract x. Oh, wait, let me do this. When I'm solving, remember, the middle of my equation is always where my equal sign is. Ooh, that was a very good job of doing that. So if I do it on the right side, if I subtract 4x on the right side, I need to come back and I need to subtract 4x on the left side. That gives me 2x on this side. Now here's the tricky part. What people are getting confused on whenever this happens, if you'll notice on the right-hand side, I just subtracted 4x, so I don't have anything left over there. And that confused people on one of the quizzes. If you don't have anything left there, there's still a value. That value is just 0. You see a 0 down there. So I can still use that 0. So I would write as my new, oh, let me give you some different color. So 0 is still over here. You can never just have one side blank. So 0 is still over here. I now have 2x subtract 2 on the left-hand side. So as my next step, I'm going to go ahead and now I need to move everything away from the x. So I need to get that 2 first over to the right-hand side. We always leave division for last. Remember, so I want to divide by 2 right now. Division is last. So that means I'm going to say, okay, well, plus 2 would get that to go to 0. Cancel out. But that means I got to do plus 2 over here. Whatever I do on the left-hand side of the equal sign, I got to do it on the right. Think about the seesaw and the example I did with bags of sugar. So now I get 2 over here, and that equals 2x. Now my last step, as we've talked about, is normally division. Go back to red, and we would divide by 2, divide by 2. So as our final step, we get x equals 1. 2 divided by 2 is 1. So that's only the first part. Again, we need to come back up and we just say, okay, well, if I know x equals 1, I still need to know what y is going to equal from the solution. So I just go back up and I plug in what x equals, and I can do it for either of the equations. I always try to pick the easiest equation. So the easiest equation to me looks like the top one. So if I come back down and I say, all right, well, I know x equals 1, and I know y equals 2x subtract 3. So if I write down, right, whole thing, y equals 2x subtract 3. I know x equals 1, so y equals 2 times 1 subtract 3. Y is going to equal then negative 1. 2 times 1 is 2. 2 subtract 3 is negative 1. So an ordered pair that works for both of these equations, and this is the only ordered pair, you never have 2 solutions or 3 solutions or 4 solutions. It's either 1, none, or an infinite. It would be 1, comma, negative 1. If we graph those two lines, it's that point right there, that ordered pair where those two lines would cross, because that's the solution of the equations. I'm going to do one more that's a little more complex to make this video a little bit longer and larger file. I won't go into two in one video. So clear all that. So now, let's go back up to the top. All right, 2 new equations. This one's going to be a little bit trickier. So let's say we have 3y equals, and we'll say 6x plus 9. I'm going to make this kind of easy for me. So now I'm going to go ahead and say, so let's say I make this, I'm trying to figure out something that's going to help even. It's going to come out kind of similar to the last one, but that's fine. So let's say I make this then 4x and then plus 2y. Oh, shoot. No, we don't want to do that. Plus 2y, and that's going to equal -2. I think should make this come out nice and even. It'll work no matter what. I just try to make the numbers nice and even. All right. So here's my challenge. I'm going to do this by substitution again, but if you'll notice in this problem, I don't have just a nice, easy setup where y equals something. I have 3y equals 6x plus 9, but I can't substitute in 6x plus 9 for y. I need to figure out exactly what y equals. So there's going to be an initial step in this. So like we talked about in the example with bags of sugar, I can do anything I want to with an equation as long as I do it to both sides. Because right now, 3y equals 6x plus 9. I can change both sides as long as I do the same thing to both sides. And my goal is to get y all by itself. Well, the way I would get y all by itself in that top equation is I need to divide it by 3. Just like if we were solving out an equation, the last step would be division. Same thing there. If I divide, so if I have 3y, and if I want to get just y, I would divide that by 3, because the 3's are going to cancel out and go to 1, and then y is going to be left all alone. So here's what I need to do, though. Again, this is the middle of my equation, or my seesaw, If I divide by 3 on the left, I need to divide both of these terms over here by 3 also. And the reason I'm doing it twice is because technically, I'll draw it in, technically it's like dividing this whole side of the equation by 3. So it's kind of the same thing as doing this right here. Oops. Same thing as doing this right here. The whole side of that equation has to be divided by 3, not just one term. And that's the equivalent of saying 6x divided by 3 plus 9 divided by 3. Same thing. So when I divide this out, I'm going to rewrite this and do it over again. So again, this is the same thing down here that I'm doing. The next step is really the same step. I'm just rewriting it a different way. 6x divided by 3 plus 9 divided by 3. Both of these are mathematically correct. I just think it's maybe easier to see if I do it this way. So now I get y, all right, this like this, equals 6 divided by 3 cancels out and becomes 2x. And then 9 divided by 3 cancels out and becomes 3. So now I know that y equals 2x plus 3. I can use that to substitute in the second equation. So 4x plus 2y equals 2. Equals -2. I just solved out, and I know that y right here is the same thing as 2x plus 3. So I just write 4x. Do a better job of that. 4x plus 2 times, so instead of y, I just write 2x plus 3. And I know that equals -2. Nothing changes with the right side of the equation. So all I did is I plugged in for the y, and I just substituted in 2x plus 3. So now I'll go to green. So now I'm just going to do the distributive property. That's the only thing I'm going to do in this first step. I get 4x, nothing changes there. 2 times 2x is also 4x, and I get plus 6 equals -2. So now I say, all right, well, let me combine some like terms, which I have right here. I don't subtract 4x. That's a mistake in the sugar video. I just said, okay, well, 4x plus 4x is 8x. So these two combine and become 8x plus 6 equals -2. I just solve it. I want to get the x all by itself. I save division for last, so I don't want to divide by 8 right now. So I'm going to go and say, well, I need to subtract 6 then if I'm going to wait to divide by the 8. That gives me 0. If I do it on that side, I need to do it on that side. Let me draw my dividing line. Again, that's like the seesaw. If I do it on one side seesaw, I got to do it on the other side. So I now get, I bring down the 8x, I get 8x equals, and that's -8, -8, so I get x, oh, not skip steps. So now to the last step, I'll go back and divide by 8 on both sides, again, left side and right side separated by the equal sign. So now I get x equals -1. Well, that's part of our equation, but we need to know what y equals. As I could plug this -1 back into any equation. I could plug it in for 3y equals 6x plus 9. I could plug it in into the 4x plus 2y equals -2. Or I can plug it into this middle equation in blue, where y equals 2x plus 3. That looks like the simplest equation to me, so I'm going to plug it back into that. Y equals 2x plus 3. Back to the black, so y equals 2x plus 3. And if x is -1, I would just say y equals 2 times -1 plus 3. Solving this out, I get y equals -2 plus 3, and I get y equals +1. So the solution for this particular problem, x would be -1, y would be 1. That is the only point, the only ordered pair that will solve both equations. If we graph the two lines, that should be where our lines cross, right there. That's what the solution is, where the two lines cross. I'm not going to go through and prove that both of those work, just because the video is already pretty long.